Hello, this is my homework 10 for ECN 423 Digital Systems. So, we had to do two modifications to two machines we've already created before. A traffic light and or a vending machine. So I chose to do either or, which means I've done a traffic light modification and a vending machine modification. So for the traffic light modification, I created a process right here. It's considered a counter component. It basically counts how many cars initially trigger the east-west directional change. Even if the sensor is triggered anywhere between that transition, it won't count that car. It only counts the initial car that sets off the chain reaction. Beyond that, the code remains mostly the same, excluding this new output counted and this new process block, like I said earlier, that keeps track of the amount of cars that have triggered the east-west direction. As before, north-south green, east-west red, waits for a car in the east-west, transitions, comes back through. So the test bench for that, like before, pretty much the same, excluding the new variable counted, which we can see the count of how many cars have triggered the system. But yeah, beyond that, pretty basic component instantiation. So I've already generated the waveform in the next window, and as you can see right here on my first, well, not my first, on this clock edge, I've detected a car. So I'm transitioning the east-west direction, and I've incremented the count. So one car has triggered the east-west direction trigger. And then I go back to the north-south being green here, and east-west being red. So I'm back in state 0. But then here I detect another car again, right on this edge. And then it increments count, does a transition, and comes back. So the FSM data path is the counter. The counter receives what state from the FSM, and the FSM outputs what count it has for the system. So that will be the data path between the FSM and the counter. So that concludes part 1 of this. So I went ahead and started part 2, which is the second modification, which is in this case a vending machine. So as before, all I did was add a process block which acts as a counter component, and it will increment every time something is vended from the machine. So all it does is look for state 8 or state 9. Then it increments count and sends the count out to the FSM. So the data path is the current state and the count, and that will be the data path between the FSM and the counter. So as before, you put in a nickel, go to state 1, put in a dime, state 2, etc., and you keep going until you've reached the amount, which is 40 cents, to dispense your item. If you put in more than 40 cents, which is the maximum possible is 45, then you'll get dispensed change. But we know this works, so we're not going to spend all the time on that. So our test bench is pretty straightforward. It's the exact same thing as before, with a few modifications, like I said, with the counted output, which lets us know how many items have been counted in the system from the counter. So in this, I don't need to test if the nickel and dime input work. I'm always putting in the maximum amount, which is a dime, so I can see if the vend counts up every time I vend an item. So in my waveform right here, as you can see, after a few clock edges, I vend something. After I vend it, the count goes up. And this happens repeatedly from 1 item to 2 items to 3 items. and this will happen so on and so forth as high as the counter can count. So part 2 is working correctly, and that should conclude homework 10.